I wear many hats, so community all across. So I'll just kind of, do a few highlights. So who knows what this is? This is a handbag made out of an H100 replica. It sells for $1,000 on eBay, right? It's a fashionable piece. It's much cheaper than the original, but it just shows the zeitgeist, right? Like everybody is excited about AI, but it's hard to place. Where are you in AI? Like who knows everything about the AI landscape? Who knows where exactly you are, where you want to go, where you want to be? If there are people like this, please talk to me. I don't think there is anybody who knows even, like, where are you on the map, right? Like, in any map on the city, so you are here, then you know where you want to go. If you don't know where we are, how do we know where we want to go? This is a problem. So, we propose a framework, and we're going to talk about it here. We propose to talk about knowledge and AI, right? AI is only good and useful for business, not research, if it solves something in the real world. And every real business knows something about the real world which is distinct. So for instance, Coca-Cola is not a soda company. Coca-Cola is a distribution company, right? Coca-Cola knows logistics around the world. It knows how to make soda around the world, package it, and ship it, and retail it. And it happened so because it was a supplier to the US Army, which was stationed around the world during the Cold War. So thanks to the USSR, we now have Coca-Cola everywhere, right? And so this kind of knowledge is hard to capture. It's distinct business knowledge, which a company has, your customer service has, your crypto company has, your bank, right? So we need to capture this knowledge in the applications. And so currently we're talking about, general purpose models. They're not capturing your business knowledge. They're capturing world knowledge. They're not capturing knowledge unique to your specific business. So we propose to look at the flow of knowledge through a full stack open source application. And the way we do this, we look at input, transformation, and output. And so input is where, structure is extracted. You shouldn't think of structure as syntax. You should think of structure as semantics. You extract a representation which has meaning. So an example is a recent project called Docling. Who heard about Docling? It's a #1 PDF parser. It's at some point it was #1 project on GitHub. It's for my former colleagues at IBM. So it extracts semantic structure of a PDF in Markdown format. And so basically, sections becomes a tree. So you don't think of this as textual elements. You think of this as a tree of meaning, right? And you should really reason about all kinds of data this way. Like the structure is actually meaning, right? Subsumption, containment means this is a detail, right? A caption, or what kind of table is this? Where is this table attached to? Name entities within sections, pronoun resolution. All of this, you should think of this as kind of knowledge which you extract and you never lose it. You keep enriching it. And you never, first of all, lose the knowledge, you never unbundle it, and you don't invalidate it, right? It keeps being valid. So whatever record it is becomes an invariant, and you pass it through, and you transform it only in a way which does not lose knowledge, right? So I'm a huge fan of Pydantic. I'm very fortunate, we're very fortunate that Python community picked Pydantic for various, often random reasons. But Pydantic is basically a type system, right? So if you come from typed languages like Java or C++ or Haskell, you know this is extremely valuable, right? If you use Pydantic records, then the knowledge will be bundled, and it will keep going around, and you will validate that it's still the same type. So it's very important that you transform things. And these records can be basically stored in various ways, right? And we can put, embeddings in them, and we can store them in knowledge graphs, and they can be building blocks of the memory. And finally, when the times come to do something in the world, your agents should take action, do something, provide some output, actuate a robot, right? You do basically structured output, which emits a semantically correct action, which is, for instance, a receipt, right? You want to give a receipt which you learn, infer. The receipt should have sections, they should have headings, and it should also have a feature that all the numbers add up together, right? So this is both syntactically and semantically cohesive invariant. And so you obey this invariant, and if you do this knowledge flow through the application as I described, then you will guarantee that your final output will be semantically correct. So this is kind of the way we propose to think of knowledge. And so OAKS is a social collaboratory. We basically are very fortunate at Neo4j that we integrate with dozens of open source partners. We're a graph database. And we do not sell open source products. Like, we do not sell GenAI products. We provide this graph database, right, which is, for almost 20 years has been the most reliable way to store knowledge graphs. So what happens is all our GenAI work is in open source, and most of this is basically pairwise integrations. So we work with LangChain and Llama Index and VV8 and Milvus and Pinecone. Like, it can be open source, it can be closed source. We have tons and tons of open source collaborations. And so, like, we're very fortunate that we're kind of in the center, right, of this knowledge ecosystem, and we know a lot about people who store knowledge and what does it mean. So, so we kind of have these building blocks, which are both our partners in their projects. We have production-grade packages, with LangChain, with Llama, is maintained by both companies, updated regularly. And examples like when Pydantic version is bumped, then of course we have to do this because we use it and they use it. So, this is basically the flow, and I added AI memory here as a distinct feature, which is emerging now, I think, especially because agents need to store what they know, the state of the world, somewhere. And so, this storage has to happen at many levels. It can be your operational storage, like what does the agent know at this very moment? What do you know about your days of work? What do you know about your goal? What do you know about your team? What do you know about your company's memory? What does the company know, right? Because some people can know something about customers. What do you know about your, human knowledge in general, and institutional knowledge, and furthermore, like global knowledge, right? So memory can exist at multiple levels, and eventually, I bet that agents will have to consult all levels of memory, and you will have to be able to distinguish this. And in Neo4j, you can give properties to nodes, and you can have graph overlays, and you can have features to relationships. So this is a project which we're specifically building right now in the design stage. It's called Agent and Service Knowledge Graph. So we want to take all the MCP servers in the world, and we want to put them in a big knowledge graph. And we're going to use a standard for the data representation called Croissant. Who heard about Croissant? Croissant is a new format from Google for data sets in machine learning. It's basically a JSON schema for a files in a data set. And there is an extension to this called Semantic Croissant, which sounds weird, maybe not tasty, but that is basically an addition of ontologies to these data sets. And so it's a global working group led by folks from Europe, EU, and US. And so we basically want to develop the ontology standard, which is distributed. So if you want an ontology in automotive industry, you can solve the root kind of DNS of ontologies, and you find out who maintains it. Maybe BMW and Tesla, maybe some consortium maintains it. And then you can say, like, what is the name of this spark plug? And the spark plug should have unique name, which is identical for Bosch Repair Center, for Shenzhen manufacturing facility, and for BMW factory, which assembles the cars. Like, this is very important, that the terms you're using by all the agents in all the systems are resolving to actual unique objects in the world, right? Like, you will not do business unless you agree how you do this. So this is kind of what we want to do. We want to first align the ontologies and also figure out what MCP servers are doing, in what domains they exist, and basically what ontologies they're operating on. So we're designing this. Let me know if you are interested in participating. This is Semantic Croissant high-level slides. So they exist on Hugging Face. There are data sets. So it's a pretty advanced thing which came out of Google and friends. So some more slides of this. And so this is basically what we want to do here. We want to have this community where folks do open source activities together. They kind of figure out what to do with MCP server ecosystem and agree on the common language. And if we do this, we're basically going to have network effects, right? We're all going to succeed by making all these pieces interoperable. So this is why we're here. We want to share this knowledge and cross-pollinate it. And I have mentioned in November, we're running, again, longest running independent AI conference in the world called AI by the Bay, which is the first AI by the Bay in deep learning in 2017, so we're in cars. This is an awesome conference. Early bird is still up, so check this out. 1,000 people, like this time 10, right? And this is I don't think we have time for Q&A, so just make a screenshot if you want to follow up with me. And